Hello students, we're going to learn section 3.4, Properties of Logarithmic Functions. Here are the restrictions. Let b, r, and s be positive real numbers, with b not equaling 1 and c any real number. So there are three main rules when it comes to properties of logarithmic functions. First rule is called the product rule. Product means to multiply. So you can see r and s is multiplied, so this is log base b of the product rs. Well, to rewrite the product rule and expanding it, it's log base b of r plus log base b of s. Quotient rule. Log base b of r divided by s equals log base b of r minus log base b of s. So quotient, when you expand, we're going to use subtraction. Product, when you expand, we're going to use addition. And the last one is the power rule. So this is log base b of r to the c power. If you remember from the last section when we solved for bacterial decay and population growth, whenever there was an exponent up above the log, we can move it to the front. So log base b of r to the c is equal to, bring the c to the bottom, c times log base b of r. Alright, so example 1, expand. So we're going to look at part A, log. This is base 10. If you don't see a number there, it's base 10, log base 10 of 8 times xy to the fourth. Well, since this is a product, I'm going to expand 8xy. I'm going to expand it by using addition. So log 8 plus log x plus log y to the fourth. Now, I have an exponent here, so I'm going to move this 4 in front of the log. So this is your final answer. We expanded this log, so expand means to open up wider. Alright, example B. Here you see there's a quotient. So to expand a quotient, we have to subtract numerator minus denominator. So there's your natural log numerator minus natural log denominator. We can rewrite this square root into 1/2, and then we move the 1/2, since it's an exponent, move it out to the front. So here is your answer for part B. We expanded this single logarithm. This is called a single logarithm because there's only one log. This is a single logarithm, there's only one log. In example 2, we're going to condense. So condense means we're just going to reverse what we did in example 1. Condense, we start off with an expansion. So what they want us to do is, for our answer, there should only be one log. First thing I'm going to do is I'm going to move the 2 to the exponent. Since the bases are the same, we can combine these logs by using a quotient. So this is log x to the 5th over log xy squared. Distribute the 2. So x squared y squared in the denominator, x to the 5th over x squared is x cubed. So we are done here. So we wrote this expression as a single log. We condensed it. Alright, next, let's look at example 2b. So again, I'm going to move the 3 on the exponent, move the 2 to the exponent position. So we move the 3 and the 2. I'm going to distribute the 3 here and here because you can distribute an exponent if it's a product for the base. So that's going to be 9, and that's going to be 3, that's going to be 2, that's going to be 4. So x to the 9th y cubed, y squared z to the 4th. Now we didn't condense it yet because we have two logs. Since the bases are the same, this is base e, we can combine by using the product. So this is x to the 9th y cubed times y squared z to the 4th. Well, y's are the same base number, so we add the exponent. So now we went from 2 logs into a single log. We just condensed this expression to a single log. All right, last property. It's called the change of base formula. So the restrictions are positive real numbers a, b, and y, with a not equaling 1 and b not equaling 1. So here we go. This is log base b of y equals log y over log b. The reason why we need the change of base formula is because your calculator is only programming base 10. So if it was base 2, base 3, base 5, base 6, any bases, we have to reprogram the calculator or go to a different function. Instead of doing that, it's easier just to use the change of base formula. Because now, when we do the change of base formula, this is now log y over log b. And what do you notice about the base here? If you don't see a base number, it's assumed to be 10. So now you can enter this in your calculator, and now you will be able to get an answer. So here is part A. Log base 3 of 16. Rewrite this by using the change of base formula. Log 16 over log 3. These are now in both base 10. Put this in your calculator, so it's approximately 2.524. And here is part B. We have log base 1/2 to the 2nd power. So this now changes to log 2 over log 1/2, and it is -1. All right, have a good day.